Alright, so we'll continue with our design project. Okay, I'll just brief you. Okay, your instructions here. We have several instructions. So you are required to design a road connecting two existing roads shown in the provided topo map. So this is your topo map. You are given existing road A here. This straight line is existing road A, and then you have existing road B. Okay, so this is straight line, and then there's a curve over here. The elevation for road B here is 840 meters, and similarly road A, the elevation is also 840 meters. And for the purpose of this road, the road category is R1 rolling. Okay, R1 rolling, you can refer to this table. So this table I extract from Arahan Teknik Jalan ATJ 8/86. If you downloaded your version from the internet, it's quite likely that you don't have this table in this form. Okay, it's a bit the format is a little bit off. So I provided this table in your design instructions. Okay, so R1, this is your category. We have to choose between these roads, and for our purpose it is R1. The terrain is rolling, design speed 30, and the width of the road is 5 meters for both lanes, meaning that 2.5 meters each lane. And then you have a usable shoulder width of 1.5 meters, and no median is applicable, and you have no marginal strip. All right, and the minimum reserve width for your case is 20 meters. Okay, I have mentioned this in the other class last week. If you look at your example here, if your center line is here and your reserve width is 20 meters, meaning that you have to reserve 10 meters to the left and 10 meters to the right of your road. Okay, all within this span, it must be clear, meaning that if you have to do any land acquisition, it must be done within this reserve width, 20 meters. So 10 meters to the left and 10 meters to the right. Okay. I haven't finished with this. Reserve width. Stopping side distance we'll cover later. Minimum radius is 25 meters. Minimum length of spiral is 48 meters. Same with your example. Maximum super elevation is 0.1, 10%. Okay. Minimum radius, if you choose your super elevation is 8%, so your minimum radius is going to be 30 instead of 25. Okay, same with spiral. The length of spiral also becomes 38 meters. All right. Maximum super elevation 0.8. And then your maximum grade is 8%. This is the desirable. Okay, you can also increase it to maximum of 11. All right, and the value for crest vertical curve, k value for crest is 5, and sec vertical curve is 6. All right, so this is the values that is of our concern. Okay, scale of the topo map is 1 to 500. Road must start anywhere between point AA on road A on the west side of the map and end between point BB on the road on the eastern side of the map. So in this map, I don't specify point AA. All right. So you can start your design anywhere. Okay, your road can start from any point that you want. However, it must end between these 2 points, BB. This window, okay, you must end your design between these 2 points. Maximum super elevation is 10%. Excess of cut material is permissible, but inadequate fill material is discouraged. Meaning that you can have excess material to cut, but you must not have not enough material to fill in the fill sections. You may design your road as a straight horizontal alignment only or with a curve. It's up to you. All right. Neither design will give you advantage of the other for the purpose of this project. Okay. If you think that you can design it as a straight, then by all means go ahead. You cannot relocate the TNB power line, but you are allowed to have your road underneath the line. All right. So this is the TNB power line. TNB power line. This is the tower. These are the towers. We have 3 towers. And this is forest reserve. This is the boundary of the forest. This is the fence for the forest. Okay. If you think that you need to cross through the forest, please give your reason. Why do you need to encroach into the reserve forest? Relocating TNB power line, meaning that you cannot move. Power line will always be there. All right. So your window of 20 meters reserve must be between anywhere, but it does not touch the TNB power line. Okay. Maximum gradient on the vertical alignment here is not 5%, it is 11. Okay, there's a mistake here. This is 11. All right. Because this is we are referring to JKR ATJ. The first and the last 10 meters of the road must be straight. Okay. So before you reach this corner, if you have a curve lah, if your design is a straight one, no problem. But if your design have corners, have a curve, so the distance between point SS here to the start of the road must be minimum 10 meters. Okay, so in the example here, the distance is only 3 meters. But in your case, in your design project, if you're going to have a curve, you must make sure the distance between the start of your road to the point of SS leading of your first curve must be 10 meters long, minimum. So this ensure when people are driving into your road, they are driving here, turning into your road, they will experience a straight segment first. After 10 meters, then only they experience the change in super elevation. Alright, so the first 10 meters must have normal ground. You are allowed to use maximum allowable gradient on the vertical alignment of your design immediately at the starting and ending of your road. This is not practiced in real world, but only applicable for this exercise. It means that this is the same case as your exercise example here. It means that your gradient here starts immediately. Okay, immediately after you turn into your design road, you start climbing. So this is not a very good case lah. Okay, the best case is that the first section here must be flat. Okay, or at least 0.5 lah, like I mentioned in the lecture just now, 0.5%. So the first segment must be flat. However, in this project, I'll give you a little bit of simpler design. You can actually start your road with a gradient. The smaller angle of any junction must be not less than 70 degrees. It means that here, I think I already explained to you this one last week. The angle here, for example, this is your road. Between the angle here and here, the smaller angle here must be between 90 to 75. Cannot be less than cannot be less than 70. So in this case here is 65 and here is 75. So this one is not acceptable because it's less than 70. So the angle must be at least 70. The best case is 90 degrees. Of course, if you, for example, if you have to connect your road like this, there are treatments that you can use so that when people are entering your road, they do not have to turn very sharply. Okay, in this case, for example, so if people are coming from here, they turn into your road, they are using the larger angle. That's not a problem. But if people coming from this side, they are turning into your road, the angle is going to be small. So it's quite difficult. Okay, you still can use, but you need some other treatment to make sure that maybe you can have something going here and then curve something like that. Okay, and people from here turning out to there, to the top side of your road here, you can have an external different lane, another lane connecting. Okay, so you have other ways of dealing with this, but because our road is just a small road, okay, it is not practical to construct all these treatments for a junction. Okay, so it is easier just have it as 90 degrees or 80 degrees, something like that. All right, your vertical alignment must be designed on a A4 graph paper. You may glue together two pieces of graph paper if you require a longer plotting area. The vertical scale of your alignment is 1 to 1000 and horizontal is 1 to 500. You must have at least one vertical curve in your design. Okay, in that case here, at least one lah. You cannot just straight away go straight and say that everything is a cut, something like that. You must report the amount of cut and fill in terms of area calculated from the vertical alignment graph. Right. Once you plotted your alignment here, you're going to see you have a cut section here, and also fill. Okay. So you must calculate the area of this cut section, this one plus this one, and then calculate the fill section and report how much excess of earth that you have. Okay. Although in the real world the amount of cut and fill is given in terms of meter cube, but in our exercise we are going to assume that the width is all the same, and you just need to estimate using the area here. You shall produce 10 cross-sections drawing at 5 meters interval. 5 of the cross-sections must be in the cut section and the other 5 from the fill section. The 10 cross-sections must be continuous, for example, from change 10 to 20 or 5 to 15, etc. All right. So you can see here, you have cut section and you have fill section here. All right. So 10 of your cross section must come from this side and another 10 from this side. All right. The scale of the cross-section graph is 1 to 100 for vertical and horizontal axis. If the fill section is too deep, you may ignore the fill depth in your cross-section graph. Just plot the cross-section 3 meters below the design surface. The same instruction applies if the cut section is too deep. If the cut section is too deep, you can ignore the rest of the height. You can just consider 3 meters from the surface height of your road. Yes, it's going to be a bit ridiculous. You're going to cut maybe about 40, 50 meters, but this is just the purpose for your project lah, an example actually. Okay, in real life, most of the time you're not going to cut the hill too deep. Okay, unless you're constructing something very major project, but definitely not for a rural R1 project. All right.